Imagine that there really are parallel universes out there, and now imagine you have two that are exactly identical in every respect, all the way out to the horizon as far as we can see, down to the last little atomic detail of every single thing, with only one difference. And that's the value of a little thing called a qubit on this chip, which is a contraction of quantum bit. And that qubit is very much like a bit or a transistor in a conventional computer. It has two distinct physical states, which we call 0 and 1 for bit. In a conventional computer, these are mutually exclusive. That device is either one or the other, and never anything else. In a quantum computer, that device can be in this strange situation where these two parallel universes have a nexus, a point in space where they overlap. And when you increase the number of these devices, every time you add one of these qubits, you double the number of these parallel universes that you have access to, until such time when you get to a chip like this, which has about 500 of these bits, you have something like 2 to the 500th power of these guys living in that chip. So the way I think about it is that the shadows of these parallel worlds overlap with ours. And if we're smart enough, we can dive into them and grab their resources and pull them back into ours to make an effect in our world. Now, this may sound very odd to you and bizarre, and in fact, I am using language that a normal theoretical physicist probably wouldn't use, but this is, what I'm telling you is absolutely correct and in line with the way that these things actually work.
Welcome to another exciting episode of Is It Impossible? Today's look is artificial intelligence and transhumanism and the future of mankind. Quantum shampoo, quantum deodorant, quantum TVs, quantum vitamin C, quantum lighting systems, quantum of solace. What the heck is quantum anything? In physics, a quantum is the minimum amount of any physical entity involved in an interaction. The fundamental notion that a physical property can be quantized is referred to as the hypothesis of quantization. I hope that you said that correctly. Quantum theory describes matter as acting both as a particle and as a wave. In the visible objects encountered in everyday life, the wave-like nature of matter is too small to be apparent. Wave-like nature becomes important, however, in microscopic particles such as electrons. Niels Bohr and Max Planck, two of the founding fathers of quantum theory, each received a Nobel Prize in physics for their work on quanta. Einstein is considered the third founder of quantum theory because he described light as quanta in his theory of the photoelectric effect, for which he won the 1921 Nobel Prize. But a quantum computer works on quantum bits, also known as qubits. Qubits have special properties. They can exist in superposition, where they are either both a 0 and a 1 at the same time, and they may be entangled so that they share physical properties even though they may be separated by large distances. Quantum computers broadly are computers that use qubits or quantum bits instead of regular bits, like your normal laptop computer or desktop computer goes on bits. You might, the old days, you might have had an 8-bit system, a 16-bit system. Nowadays, more prominently, you'll see 32-bit systems and 64-bit laptop computer systems. My particular one is a 64-bit computer. A quantum computer known as the D-Wave is instead a quantum annular more than a simulator than a quantum computer. Now let me go back to the quantum bits part. A quantum computer works on quantum bits known as qubits. Qubits have special properties. They can exist, as I stated, as either a 0 or a 1, where a regular computer works on bits, which is either a 0 or a 1, where a quantum computer can exist in superposition where they are both 0 and a 1. So quantum computers are broadly computers that use qubits or quantum bits instead of just regular bits to do their calculations. A quantum computer known as the D wave is instead a quantum annealer, more of a simulator than of a computer. As of April 3rd, 2020, according to PC Magazine, with the new 10th generation Intel Core H series, the chip maker has revealed what it's called the world's fastest mobile processor, allowing gaming and content creation laptops to reach clock speeds of 5.3 gigahertz while pushing 8 cores for multi-thread workloads. Now, I will spare all the calculations that explain the differences between 1-bit computer and a 1-qubit quantum computer. So let me just kind of fast forward all through the details here, and let me just simply state this. A 3-qubit based quantum computer does calculations 8 times faster than a 3-bit conventional computer. So for another example, a 64-bit conventional computer would equal a 512 qubit quantum computer. Now, to put this in perspective, the quantum D-wave computer, the newest version of the quantum D-wave computer, codenamed Pegasus P16, and it operates at 5,640 qubits. Okay, but make no mistake, at $20 to $50 million, I'm sure Quantum Pegasus is the most advanced computer out there. Or is it? As of October 24th, 2019, Google just took a quantum leap in computer science using the company's state-of-the-art quantum computer called Sycamore. Google has claimed quantum supremacy over the most powerful supercomputers in the world by solving a problem considered virtually impossible for normal machines. In short, quantum computers are reaching further, thinking faster, and pondering the questions of the cosmos that humans or conventional computers could never dream of. In March 13, 2017, the D-Wave Systems Inc., the leader in quantum computer systems and software, announced that Google, NASA, and University Space Research Association will use the new D-Wave 2000Q, which was new at that time in 2007, the new 2000Q system to conduct pioneer research on how quantum computing can be applied to artificial intelligence and machine learning. Now, as I stated, that D-Wave 2000Q was, as of 2017, the newest system. However, today, the D-Wave, just as an example, the D-Wave 2000Q operated at 2,046 bits with 6,016 couplers, and the new Pegasus 16, as of this year, operates at 5,640 qubits and over 40,000 couplers. In addition to NASA using the super advanced technology in 2011, think of this: Lockheed Martin, the famed company of the secret projects Skunk Works, signed a multi-year agreement with D-Wave to capitalize on the benefits of quantum annealing processors for some of Lockheed's most challenging computation problems. Think of that for a moment. And the advancements, the most technologically advanced aircraft company in the world now using supercomputers to calculate things. Okay, just think of that for a moment. Now take a moment to pause, like, subscribe, and share. And tonight, as you're almost asleep, your mind will race with thoughts of artificial intelligence and our future. Stay tuned to future episodes of Is It Impossible?